Okay, so the way this is going to work is uh, due next week, um, you're going to turn in your what's going to be your final form of this design project. Then I'll get it 3D printed, give it back to you the week after that. We're going to start next week in class. We're going to start working on electronics, but then a week after that, I'm going to give you your things back, and we'll continue working on electronics while you write up your final report for the design project. You will have already written a bunch of the stuff that's going to go in the final report, so it won't be like a ton of work, but that's how it's kind of going to be. You're going to finish turning in stuff on the design project after we've moved on to electronics. And here is what you're going to turn in for the design project. First, you're going to turn in an STL file for it. So that's the format that I need for the 3D printer. And to do that, let me just show you. You're just going to export it as an STL file. Okay, so to turn in an STL file, go to your part. And go up to the file thing and go to export. And there's a long list of ways you can export it. And one of them is STL stereolithography. That's just the most kind of portable file form for 3D printing. So go to that, export, and just send me that STL file. And now here are the key things to think about this week, to consider this week. Okay, the first one is the size constraints. The 3D printer has max sizes of 8 inches by 8 inches by 12 inches. 12. So we can't do anything about that. That's just the printer that we have. If you're picturing something bigger than that, maybe you can separate it into pieces or something, but I can talk about that when I talk to you today. And then this one is not so rigid, but it would be nice. We're trying to keep stuff under a volume of 2 cubic inches. And so let me show you where to find that, how to measure the volume. Okay, so when you're in here, there is a drop-down menu called Bodies. And if you open that up, then it'll list, this one only has the one body there. And if you right-click on the body that you're interested in, it gives you this whole drop-down menu, and go to Properties. And the volume is listed right there. For this shape that we did in class, it turns out the cubic volume is 0.23 cubic inches. Okay. So if your object has a volume that's bigger than 2.0 cubic inches, there are almost always ways to decrease the volume quite a bit. You can make the walls thinner. Parts that are solid in your current design, you can make hollow. So let me know if you want some suggestions. If there's no way to get your part under that, I mean, we should just talk about it. It's not a super rigid requirement, but this material is fairly expensive. Yep.
So it's the volume of the actual material used, not like the fluid volume.
Correct.
Okay.
Yes. So that's a big. So just go and check your part, and it might be smaller than you would imagine. Right. Any other questions about that? The way I'm going to grade this stuff eventually, like your final submissions and everything like that. So let's talk about that. So your grade is going to be largely based on the first thing is, how is it different from what's available? You're going to turn in a slightly more formal report on what you found available on the internet. And what you're going to turn in can't just be a copy of other stuff that's out there. So you can add features to it. You have to have a justification for why your differences from what's available is useful. Remember that your reasons for making it different from what's available, feel free to make those personal to your specific uses, So like if you're making some kind of cord organization device or something, you can make it specific to the types of power cords that you have on your desk. That's great, So, but it can't just be essentially the same thing that you can go buy on Amazon. Okay. So these differences can be specific to you. Oh, like somebody's doing sort of a drawer organizer type thing, like everybody has different stuff in their drawers. Feel free to make it as useful as possible for yourself, The second thing is what details does it have that make it useful and easy to use. The third thing is you should be considering aesthetics. Consider where it's going to sit on your desk in here, what makes it sort of fit in with the surroundings. You don't want it to stand out as something that's ugly. Okay. So consider its surroundings. Third, you should give some thought to durability. You don't want to make something that you have to make every 2 weeks, because it's going to break. And then the last one is how well you articulate your thought process. Okay, so you're going to have to write up how you made these choices, including these kind of things. And so as you're making these changes, you should be taking notes, preparing to give a little bit of a write-up of what the appealing properties of your product. Okay. Anybody have any questions about that? Okay. Well, that's all for me today. So I'm just gonna go around. Go ahead and start working on your thing, and I'll just go around, answer questions, make suggestions, that kind of thing. Yep.